Yeah, good evening, children. I've shared my screen. It's a blank screen. Is it visible?
Yes, ma'am.
Okay. Yeah. So let's recall the concepts, the terms which we have understood in the last session. So what is a curve? A curve is a figure that's traced on a plane surface using a writing instrument without lifting your hand. And then what is an open curve? What is an open curve? Can I get the answer from you? What is an open curve?
Ma'am, when the starting point and the ending point is not the same.
Yeah, correct. A curve that does not end at the starting point. A curve that does not end at the starting point. That means the starting point and the ending point are different. Is an open curve. What's a closed curve? What's a closed curve?
Ma'am, when the starting point is equal to the ending point. Ma'am, when the starting point and ending point is same, ma'am.
Correct. If the curve ends at the starting point, if the curve ends at the starting point, it's a closed curve. What is a simple curve? What's a simple curve?
If the curve does not intersect itself.
Correct. A curve that does not intersect itself or cross over itself. A curve that does not intersect itself or cross over itself is a simple curve. Now this one is not a simple curve because it crosses over itself. Now this one is a simple curve. This one is a simple curve because it doesn't cross over itself. While this one is not a simple curve because it crosses over itself. But both of them are open. Both of them are open curves. Both are open curves because if you regard this one as a starting point, this is the ending point. So the starting point and the ending point, they're different. So it's an open curve. It's an open curve and it's also not a simple curve. This one is not a simple curve. This one is an open curve, starting point, ending point. It's an open curve, but it is a simple curve because it doesn't cross over itself. And we understood that a polygon is defined as a simple closed curve made of line segments. If all these conditions are satisfied, then that figure is a polygon. A polygon is a curve. That means you should be able to draw the polygon without lifting your hand. A polygon is a curve, which means you should be able to draw it without lifting your hand. A polygon is a closed curve. That means when you draw, it should end at the starting point. Also, the curve should not intersect itself. It should be a simple closed curve. A polygon is a curve. It's a closed curve. It's a simple closed curve. That means it should not intersect itself. And also, it should be made of only line segments. All these four conditions must be satisfied for a figure to be called a polygon.
Ma'am?
One second. A polygon is a curve. A polygon is a closed curve. A polygon is a simple closed curve. And a polygon is a simple closed curve made of only line segments. So this figure is not a polygon because you can see two line segments and two other pieces which are not line segments. So this one is a curve. It is a simple closed curve, but it is not entirely made of line segments. And hence it's not a polygon. It's a simple closed curve, but not a polygon. Yeah, Navneet, what's your question?
Ma'am, your voice is hanging, ma'am.
Srijit, can you hear me clearly?
Yes, ma'am, I can.
Okay. Sriharini,
Ma'am.
it's not clear?
Yes, ma'am.
Okay, we'll just see as it progresses. Just let me know again. Okay. Is it okay now?
It is okay, ma'am.
Okay.
Okay.
Navneet, just close the door. I think that should make a difference. Navneet, close the door.
Yes, ma'am.
Yeah. All right. Then we understood the classification of polygons. A polygon with 3 sides is called a triangle. 4 sides it's called a polygon with 4 sides is called a quadrilateral. A polygon with 5 sides is called a pentagon. A polygon with 6 sides is called a hexagon. A polygon with 7 sides is called a heptagon, or you can also call it a septagon. 7 sides. Septagon or heptagon. 8 sides. 9 sides. Yeah, 9 sides. Nonagon. Not nanogun. Nonagon. 10 sides. Decagon. Very good. What do you understand by a concave polygon? What is a concave polygon?
A polygon in which at least one angle is greater than 180 degrees or more than 180 degrees. A polygon has at least one angle that is
More than 180 degrees.
Yes, ma'am. More than 180. One angle should be more than 180 is concave polygon.
Correct. At least one angle. There can be more than one angle. There can be more than one angle. Now look at this one. I'll just draw. See, not a very good artist, but I can just try to. Yeah. Can you see here? See here? This angle, this one is more. See, these, I'll just mark the interior angles. In this polygon, I'll mark all the interior angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now this polygon has 11 sides. So 11 interior angles. This polygon has 11 sides. It's 11 gun. It has 11 sides. So 11 interior angles. Now name all the, tell me all the angles which are, reflex angles. Is angle 1 reflex? Okay. Reflex angle meaning an angle which measures more than 180 degrees but less than 360 degrees. An angle that measures more than 180 but less than 360 is a reflex angle. So name all the reflex angles in this polygon.
Angle 10, angle 11, angle 2, angle 6, angle 8. Angle 10, angle 4.
Okay. Is angle 1? Okay, let's make it. No. Let's no. Just answer my question. Is angle 1 reflex?
No.
No. Is angle 2 reflex?
Yes. Yes.
Angle 3?
No.
Angle 4?
Yes.
Angle 5?
No. Yes, ma'am. No.
Angle
No,
6?
ma'am. Yes, ma'am.
Angle 7?
No, ma'am.
Angle 8?
Yes, ma'am.
Angle 9?
No, ma'am.
Angle 10?
Yes, ma'am.
Angle 11?
No. Yes, ma'am. No, ma'am.
This one.
No, ma'am.
Okay. So you can have a polygon. You can have a polygon. You can have a concave polygon in which more than one angle is a reflex angle. You can have a polygon. You can have a concave polygon in which more than one angle is a reflex angle. But how do you identify concave polygons? A polygon in which at least one interior angle. If at least one interior angle is a reflex angle, that is measures more than 180 degrees, it's a concave polygon. Now here we have many angles. All right. And what's a convex polygon? What's a convex polygon?
Any one angle is greater than 180. Ma'am, a polygon in which all the three angles are less than 180 degrees. All the angles. Any one angle. Ma'am, all the angles. Yes, ma'am.
All the angles what?
Less than 180. Oh, see? But one angle will be more than 180, right? That's concave.
Yeah. So convex polygon. A convex polygon is one in which all the interior angles measure less than 180 degrees. See, we understood it like this, like an acute triangle and obtuse triangle. Obtuse triangle, right triangle. How do we understand these triangles? Obtuse triangle, right triangle. In an obtuse triangle, one angle is obtuse. Here also one angle is right. But in an acute triangle, all angles are acute. All angles are acute. In the same way, in a convex polygon, all interior angles measure less than 180 degrees. A convex polygon is one in which all the interior angles measure less than 180 degrees. If the polygon has 15 sides, it will have 15 interior angles, 15 exterior angles. A polygon with n sides will have n interior angles and n exterior angles. Now, if it's a convex polygon with 15 sides, supposing it is a convex polygon with 15 sides, all the 15 angles will measure less than 180 degrees. If we talk about a convex polygon with 15 sides, it will have 15 interior angles. All these 15 angles will measure less than 180 degrees. Each of these 15 angles will measure less than 180 degrees. But if it is a concave polygon with 15 sides, at least one angle will measure more than 180. There can be two angles also with magnitude more than 180 or three angles, but to be called concave, there should be at least one angle. To be called concave, there should be at least one angle in the polygon, one interior angle in the polygon, which measures more than 180 degrees. Yeah, Navneet, Danvin, Harini, and Anirudh, is my voice clear?
Yes, sometimes it's breaking up, but we can hear it. Yes, ma'am. Yes, ma'am.
You're able to, no, you're able to comprehend what I'm explaining, right?
Yes, ma'am.
Okay. What about Srijit?
Yes, ma'am.
Okay, very good. So that's about concave and convex polygons. Now regular polygon. What is a regular polygon? What is a regular polygon?
A polygon in which all angles and sides are equal.
Correct. A polygon in which all the sides and all the angles are equal is called a regular polygon.
Angles also equal. Yes,
Yes.
square, right angle. 360 that one. Okay.
Yes. A polygon in which all the, see, if it's a heptagon, okay, if it's a heptagon, if you call it a regular heptagon, okay, you have a regular heptagon. Heptagon is a polygon with 7 sides. Now, if it's a regular heptagon, all the 7 sides will have the same length, and all the 7 interior angles will have the same measure. All the sides will be equal in length, and all the angles, all the interior angles will be equal in magnitude. Equal in magnitude. In a regular, for example, in a regular heptagon, a heptagon is a polygon with 7 sides. In a regular heptagon, all the 7 sides will have the same length, and also all the 7 interior angles will have the same magnitude, will have the same measure. Also the 7 exterior angles. If a polygon has 7 sides, it will have 7 interior angles and 7 exterior angles. Each of the exterior angles also will measure the same. Each exterior angle also will have the same measure. All the 7 exterior angles, they'll have the same magnitude. All the 7 interior angles, same magnitude. All interior will have one magnitude. Exterior will have a different magnitude, but all the exterior will have the same magnitude. And all the sides would be equal. That's a regular polygon. Now name a regular quadrilateral. Name a regular quadrilateral.
Ma'am, square.
Square. Yeah. A square is correct. A square is a quadrilateral because it's a polygon with 4 sides. And it's a regular quadrilateral because in a square, all the 4 sides are equal and all the 4 angles are equal. Each angle measures 90 degrees. So a square is a regular quadrilateral. What about a regular triangle?
Equilateral triangle.
Yeah, equilateral triangle. Because in an equilateral triangle, all the 3 sides are equal and all the 3 angles are equal in magnitude. Each angle measures 60 degrees. Okay. So an irregular polygon is a polygon that is not regular. That's all. If a polygon is not regular, it is irregular. So supposing in this heptagon we were talking about 6 sides are equal. The 7th side has a different measure. Then it is not regular. A heptagon has 7 sides, right? Now in this heptagon, if supposing 6 sides have the same length, but that 7th side has a different length, that means all the 7 sides are not equal. Then it is not regular. You cannot be, like a liberal in using the word regular. Strictly all 7 sides must be equal. 6 sides are equal. One side has a different length. It's not regular. Regular means all the sides must be equal and all the interior angles must be equal. Now, if you take a rectangle, see, all the angles are equal. So you cannot call it regular. No, you cannot call it regular. Because all the angles are equal in a rectangle, you cannot call a rectangle a regular quadrilateral because both the conditions must be satisfied. all sides must be equal. All angles also must be equal. Both the conditions must be satisfied.
Yes, ma'am.
Yeah, so in a rectangle, all angles are equal. Okay. Are all the sides equal? No, only opposite sides are equal. All sides are not equal. So rectangle is not a regular quadrilateral or a regular polygon. A rectangle is an irregular polygon. Rectangle is an irregular polygon because both conditions must be satisfied. All sides must be equal. Here only opposite sides are equal. So a polygon that is not regular is irregular. Okay, then we also understood the formula. Okay, and what's the formula to find the number of diagonals in a polygon?
N into n minus 3. N into n minus 2. N minus 3 divided by 2, ma'am. Ma'am, n into n minus 4. N into n minus 3 divided by 2, ma'am.
Very good, very good. N into n minus 3 by 2. N into
minus 4.
No, that's different. That's not.
Ma'am, your voice is breaking.
One second, I'll just come there and check. Just a minute.
Ma'am?
Yeah, thank you, children. I'm back. So the formula to find the number of diagonals in a polygon is given by n into n minus 3 by 2.
Yes, sir.
Where n stands for the number of sides the polygon has. N stands for the number of sides the polygon has. So if it is a polygon with 20 sides, so then n is 20. N is 20. And you'll have to work that, simplify that and get the answer. Now, what's the formula to find the sum of all the interior angles? Formula to find sum of all interior angles.
N
of a polygon.
From 2 and minus 4.
We'll for now learn n minus 2 into 180. We'll see. See, I don't know if your school uses 2n minus 4 into 90. We'll just use this now.
Okay, ma'am. N minus 2 into 180.
Yeah.
N minus 2 into 180.
N minus 2. Yeah, because a polygon with n sides. Let me write here. A polygon with n sides can be divided into n minus 2 triangles. Srijit, kindly disable your mic. You can unmute when you want to say something. A polygon with n sides can be divided into n minus 2 triangles. For example, see here. So 1, 2, 3, 4, 5, 6, 7. This is a heptagon. This is a heptagon. A heptagon has 7 sides. And you can divide this into 5 triangles. 2 triangles less than the number of sides. This one is a heptagon. 1, 2, 3, 4, 5, 6, 7 sides. It's a heptagon. Heptagon has 7 sides. And you can divide the heptagon into 7 minus 2. 5 triangles. How? Choose any vertex. Choose any vertex. And from there, keep joining to make triangles. Okay. So see here. This is one triangle. This is a second triangle. This is a third triangle. Fourth and fifth. You can see that we have divided the heptagon into 5 triangles. Like how you fix puzzles, you know, if you have these 5 triangular pieces, you can fix them together and make the heptagon. So what is the sum of all the angles here? The sum of these angles here, 180. The sum of these angles, 180. So everywhere, 180. So the sum of all the interior angles of a heptagon is equal to, how many triangles are there? N minus 2 triangles. One triangle, 180 degrees. N minus 2 triangles, N minus 2 into 180. It's like one book costs 180 rupees. So 5 books will cost 5 into 180. 10 books will cost 10 into 180. N books will cost N into 180. X books will cost X into 180. So N minus 2 books will cost N minus 2 into 180. This is just an example we're taking up. A heptagon has 7 sides. We can divide the heptagon into 7 minus 2, 5 triangles. The sum of all the angles in a triangle is 180 degrees. So 5 triangles, 5 into 180. 5 into 180 is 5 into 180 is 900 degrees. So the sum of all the angles, the sum of all the angles, the sum of all the interior angles. A heptagon will have 7 interior angles because 7 sides, no? So 7 interior angles. The sum of all the 7 interior angles of a heptagon is equal to 900 degrees. One, 2, 3, 4, 5, 6, 7. The total of all these angles, angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 is equal to 900 degrees. Like the sum of the angles in a triangle is 180, quadrilateral 360. So like that, the angle sum property of a heptagon is 900 degrees. So remember, a polygon with n sides can be divided into n minus 2 triangles. 2 triangles less than the number of sides. So the sum of the angles in one triangle is 180. So n minus 2 triangles will be n minus 2 into 180. And that's the formula to find. That's the formula to find the sum of all the interior angles of a polygon with n sides. N minus 2 into 180 degrees. Now, if this one is a regular polygon, if it is a regular polygon, then each angle will be equal to n minus 2 into 180 by n. Because the sum of all the angles is n minus 2 into 180. Now it's regular. That means all the angles are equal. So how many angles are there? N angles. How do you know? Because n sides means n angles are there. So each angle will be the total n minus 2 into 180 by n. Because n is the number of angles also. Divide by n angles. In the case of a regular polygon, because all the angles will be equal, each interior angle in a regular polygon, the measure of each interior angle in a regular polygon, the measure of its each interior angle is equal to n minus 2 into 180 divided by n. Now, the sum of all exterior angles of a polygon, the sum of all exterior angles of a polygon is equal to 360 degrees. And in the case of a regular polygon, in a regular polygon, each exterior angle will be equal to, the total is 360. See, in any polygon, 3 sides, 4 sides, 5 sides, 6 sides, in any polygon, the sum of all the exterior angles is always 360. In any polygon, that is irrespective of the number of sides.
360.
The sum of all the exterior angles is equal to 360. So if it is a regular polygon, each exterior angle will be 360 by n. Because there are n angles, no, n sides, so n angles.
Number of sides.
So they'll divide 360 degrees equally. 360 by n. Also remember that each interior angle plus each exterior angle is equal to 180 degrees. Each interior angle plus each exterior angle will be equal to 180 degrees. All right. So this is what we had seen in the last class. Since it's a completely new chapter, I just thought, we'll have a recap and then proceed with today's session. But it will not always be like this. You have to do your homework. When something is taught in the class, you need to revise and come prepared for the next session. Every time we cannot recall, what we have learned. Like in detail, we cannot recall whatever we've learned in the previous session. So that's your, responsibility. You need to come prepared for every session. Go through what was taught in the previous class. Practice them. If we have started with problems, you need to practice them and come prepared for the next new session. Okay. So now in today's session, we are going to understand the different types of quadrilaterals and their properties. Okay, we're going to see different types of quadrilaterals. You can call them special quadrilaterals and their properties. Now, what is a quadrilateral? We're going to learn about, see, now the chapter, we started with curves and then we understood polygons. We know the different types of polygons. Now we are going to study only about quadrilaterals. Okay, a quadrilateral is a polygon, right? A quadrilateral is a polygon with 4 sides. Now we are going to study in detail about the different types of quadrilaterals and their properties. Okay, so for that we'll understand how a quadrilateral is formed. How is a quadrilateral formed? We know that a quadrilateral.
Your voice is not audible, ma'am.
Rejoin, Srijit, leave the meeting and rejoin and try. What about the children here? Navneet and others? Am I audible?
Ma'am, we can hear clearly. We can hear clearly.
Thank you. Very good. Just wait for Srijit. Yeah. Are you there, Srijit? Srijit, I can hear from your house. You can't hear me? Srijit, disable your mic and enable it if you want to say something to me. Please disable your mic, Srijit. Okay. So we know that a quadrilateral is a polygon with 4 sides. Now, how is it formed? To get a quadrilateral or to form a quadrilateral, we need 4 points in a plane. To form a quadrilateral, we need 4 points in a plane. Now say I take 4 points like this. I have 4 points, no? I'll join. Array, I'm not getting a quadrilateral. I thought if there are 4 points, I can get a quadrilateral, but no, I'm not getting. See here, I have 4 points. No, 1, 2, 3, 4. I'm trying to join them. Oh no, I'm disappointed. No quadrilateral is formed. So what I do? So now what do I understand from this one? If the 4 points are collinear, no quadrilateral is formed. If the 4 points are collinear, that means they lie on the same straight line. Collinear. If the 4 points are collinear, they lie on the same straight line. No quadrilateral is formed. Okay. So now what I do, I'll just try to put 1 point away. Now I'm like happy. I'm like, okay, I'm going to form the quadrilateral node. So I join. No, I'm disappointed again. I'm not getting a quadrilateral. It's a triangle. But for a triangle, we need 3 points only. No, why 4 points? Again, 3 points. If they're like this, no triangle is formed.
Ma'am, it should not be on the same line.
Yeah.
3 points should be on the same line, only 2.
Yeah, correct. So if all the 3 points are collinear, no triangle is formed. In a quadrilateral, for a quadrilateral to be formed, if all the 4 points are collinear, no quadrilateral is formed. So what I did, I pushed 1 point. First, I took points like this. Then I connected them. No, I don't get a quadrilateral. So then what I do, I push 1 point out. Now I think I get, but no, I did not. I didn't. I could only manage to get a triangle. So that means 3 points here, 3 points are collinear. These 3 points are collinear. So I did not get a quadrilateral. So now what I do, I don't make 3 points collinear. I put 2 points like this. Then I take 1 like this and 1 like this. So you can see of the 4 points, no 3 points are collinear. 3 points don't lie on a line. The first case was this. Disable your mic, Srijit, please. Okay, this is the first case. All the 4 points are collinear. All the 4 points are collinear, no quadrilateral is formed. Then 3 points collinear, 3 points collinear. No quadrilateral is formed. So now we take points in such a way that no 3 points are collinear. No 3 points. See here, 3 points are not collinear. See, 2 points you can always connect by a straight line. 2 points can always be connected by a straight line. No 3 points must be collinear. That's how we have taken. That's the arrangement we have done here, taken here. Now try to join in order. In order, you must join. What do we mean by order? See, if you have points like this, if you join like this and say, no, I did not get a quadrilateral. No, you must join the points in order. That means you must go in the clockwise or anti-clockwise direction. You should not do this. Okay. So you must go in order. You should join the points in order in the clockwise or anti-clockwise direction, any one direction. So see, now a quadrilateral is formed. So this is how we understand a quadrilateral. A quadrilateral is a figure. A quadrilateral is a figure formed by 4 points in a plane of which no 3 points are collinear. I don't know if I've given that definition here. Yeah, it's there. Okay. So a quadrilateral is a figure or a polygon formed by 4 points. You need 4 points. With 3 points, you cannot get a quadrilateral. With 3 points, you cannot get a quadrilateral. You need 4 points. A quadrilateral is a polygon formed by using 4 points or formed by 4 points in a plane, of which no 3 points must be collinear. If 3 points are collinear, no quadrilateral is formed. No 3 points must be collinear. That's the definition, or that's how a quadrilateral is formed. See the definition here. A quadrilateral is a polygon formed by joining 4 points in a plane in order. Okay, I told you that earlier. In order. Okay, in the clockwise or anti-clockwise direction. In order, of which no 3 points are collinear. Very important definition. You must memorize that. Next, talking about the parts of a quadrilateral. Parts of a quadrilateral. Srijit, is my screen visible? And is my voice reaching you clearly?
Yes, ma'am.
Very good. So every time you have that issue, if you're not able to see my screen or if my voice is not clear, just no. Suppose that happens, rejoin, leave the meeting and rejoin. That will help.
Okay, ma'am.
Yeah.
Thanks, ma'am.
Yeah. I was telling you parts of a quadrilateral. Parts of a quadrilateral. Sides, angles, vertices, diagonals. Diagonals. These are the parts of a quadrilateral. Now, when you're given a quadrilateral, supposing it's called PQRS. PQRS. Okay, so you can name the sides. You can name the sides of the quadrilateral. You can name the angles of the quadrilateral. You can name the vertices, vertex P, vertex Q, vertex R, vertex S. Angles, angle P, angle Q, angle R, angle S. Sides, side PQ, side QR, side RS, side PS. Diagonals, diagonal PR and diagonal QS. These are the different parts of a quadrilateral. Okay? The different parts. Parts of a quadrilateral meaning when you're given a quadrilateral, what all you can talk about? What are the different things you can name in a quadrilateral? So you can name its sides, angles, vertices, and diagonals. That's what you see here, parts of a quadrilateral. Okay, so in the quadrilateral ABCD, the points A, B, C, and D are its vertices. A, B, these points are the vertices. Then angle A, angle B, angle C, angle D. They are the interior angles. They are the interior angles. A, B, C, D are the interior angles. Then This is the symbol for line segment. Like this is a symbol for line segment. This is a symbol for ray. And this is the symbol for a line in geometry. All right. So line segment AB, line segment AB, line segment BC, line segment CD, and line segment AD. They are the sides. And AC and BD are the diagonals. So these are the different parts of a quadrilateral. Now the other terms we'll be using are which are the adjacent sides, which are the opposite sides, which are the adjacent angles, which are the opposite angles. These are the other things we'll talk about in a quadrilateral. Okay, so that's what you see here. Adjacent sides, adjacent angles, opposite sides, opposite angles. Okay, so order is not important, just the understanding is important. So adjacent sides, opposite sides, adjacent angles, opposite angles. So adjacent sides, which are the adjacent sides? AB and BC, they are the adjacent sides. BC and CD are adjacent sides. Adjacent sides are a pair of sides. Two sides are said to be adjacent if they have a common vertex. Two sides are said to be adjacent if they have a common vertex. So you can see AB and BC. They have a common vertex B. So adjacent sides. Opposite sides will not have a common vertex. Opposite sides will not have a common vertex. So see here, AB, BC, common vertex is B. Then BC, CD, BC, CD. The common vertex is C, this one. BC, CD, common vertex is C. So I think you understand. AB, BC, then BC, CD, then CD, DA, then DA, AB. These are the four pairs of adjacent sides. Adjacent sides will have a common vertex. Now the name, if the question is name the adjacent sides with the common vertex A. Name the adjacent sides with the common vertex A. If this should be the common vertex, which are the adjacent sides? BA and DA. BA and DA are the adjacent sides with the common vertex A, like that. Now opposite sides, we'll have two pairs of opposite sides, AB and CD, and the other pair of opposite sides, AD and BC. Or you can write AD and CB, whatever order. You know that AB, BA, both are the same. AB, BA, both are the same. So there are two pairs of opposite sides, four pairs of adjacent sides, four pairs of adjacent sides, two pairs of opposite sides. Opposite sides will not have a common vertex. You can see here, AB. These are the vertices here. CD. These are the vertices. No common vertex. That's why they are opposite sides. So that's about adjacent sides and opposite sides. Now adjacent angles, opposite angles. So opposite angles are angle A and angle C. Angle A and angle C, opposite angles. Angle B and angle D, opposite angles. Adjacent angles. Angle A and angle B. Angle B and angle C. Angle C and angle D. Angle D and angle A. So like adjacent sides, like four pairs of adjacent sides, we have four pairs of adjacent angles. We have two pairs of opposite sides and two pairs of opposite angles. Understood the different terms?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Very good. Now, very important, special types of quadrilaterals. Okay. Listen very carefully. Friends sitting together, focus. You can have fun after the class.
Okay, ma'am. Okay, ma'am.
Yeah. So now special types of quadrilaterals. Now a quadrilateral in which no pair of opposite sides are parallel is called a kite. A kite. See, now we'll be using these words, parallel and equal. Parallel, equal. Now, a quadrilateral in which no pair of opposite sides are parallel is called a kite. Okay? See, this one is a kite. This quadrilateral PQRS represents a kite. Now, in this figure, opposite sides will not be parallel. Will not be parallel means if you produce them, you know, they'll meet at a point. When you produce, they'll meet. When you produce the opposite sides, they'll meet somewhere. They'll meet at a point. That means the opposite sides are not parallel. If they are parallel, they'll not meet. If opposite sides are parallel, like the opposite edges of a table, rectangular top table, the opposite edges, they'll not meet. Even if you produce them, they'll not meet. That means they are parallel. If they are not parallel, that means when you produce them, here in the figure, they don't meet. In this figure, they don't meet. But if you produce them in one direction, you know, see, if you produce them like this, they'll not meet. They'll keep diverging. When you produce them like this, they'll meet. In one direction, in one particular direction, when you produce them, they'll meet. So a kite is a quadrilateral in which no pair of opposite sides are parallel. Opposite sides are not parallel. That means when you produce the opposite sides, they'll meet at a point. So this side, you know, if you produce it, this side, if you produce it, so produce in a straight line. So they'll meet somewhere. Similarly, these two sides, opposite sides, these two sides, when you produce them in the same straight line, they'll meet. But when you produce them in this opposite direction, this side, you know, they'll not meet. They'll diverge. This one also, like this, if you produce, they'll not meet. They'll diverge. Okay. Then a quadrilateral in which one pair of opposite sides is parallel is called a trapezium. A trapezium is a quadrilateral in which exactly one pair of opposite sides is parallel. And a parallelogram is a quadrilateral in which both the pairs of opposite sides are parallel. Okay, so we have kite, trapezium, and parallelogram. A kite is a quadrilateral in which no pair of opposite sides are parallel. A trapezium is a quadrilateral in which exactly one pair of opposite sides is parallel. The other pair is non-parallel. So a trapezium looks like this. This side is parallel to this side, opposite sides. One pair of opposite sides are parallel. This pair of opposite sides, they're not parallel because see, if you produce them like this, they'll meet. See, they meet. But these two sides, you produce them, they'll not meet. They'll keep going like this. They'll not meet. You produce them in this direction also, they'll not meet. Opposite sides, they'll not meet. A trapezium is a quadrilateral in which exactly one pair of opposite sides is parallel. A parallelogram is a quadrilateral in which both the pairs of opposite sides are parallel. That means this is parallel to this. Also, this is parallel to this. This is how we indicate parallel lines. We use an, sort of arrowhead like this. Okay. This arrowhead says that the lines are parallel. The single arrows here, the single arrowheads here, these two sides are parallel, and the double arrowheads, these two sides are parallel. In a parallelogram, both the pairs of opposite sides are parallel. This side is parallel to this side. This side is parallel to this side. Both the pairs of opposite sides are parallel. Now, there are some special types of parallelograms, which are called rhombus, rectangle, and square. Rhombus, rectangle, and square are special types of parallelograms. So we have seen kite. So far, we have seen kite, parallelogram, trapezium, kite, trapezium, parallelogram. And parallelogram, we have three special types: rhombus, rectangle, square. No pair, kite, no pair of opposite sides are parallel. Trapezium, one pair of opposite sides are parallel. The other pair of opposite sides are non-parallel. Parallelogram, both the pairs of opposite sides are parallel. Special types of parallelogram: rhombus, rectangle, square. All these are parallelograms. A rhombus is a parallelogram. A rectangle is a parallelogram. A square is also a parallelogram. So if these are parallelograms, that means opposite sides are parallel. Both the pairs of opposite sides are parallel. Yeah, I didn't mention the types of trapezium for you. Trapezium also we have types. Or we have scalene trapezium. Or we have a right trapezium. No, we don't have an equilateral trapezium. We have a scalene trapezium, right trapezium, and isosceles trapezium. Okay, that's all. No obtuse trapezium, acute trapezium. We have only these three. Or we have something called a scalene trapezium, right trapezium, and isosceles trapezium. I'll just come back, read the contents of the slide. I'll just come back. The slide shows what I just explained. Special types of quadrilaterals. Just go through, I'll come back.
I'm finished, ma'am.
Yeah, thank you, children. I'm back. Now let's learn the properties of each of these quadrilaterals, special quadrilaterals in detail. Are we ready?
Yes, ma'am. Yes, ma'am.
Okay, good. Let me call this quadrilateral PQRS. Okay. Now, PQRS is a kite. PQRS is a kite. In a kite, we know that no pair of opposite sides are parallel. That means PQ and RS, they're the opposite sides. PQ and RS, they're opposite sides. They're not parallel. Similarly, PS and QR, they're opposite sides. PS and QR, they're not parallel. They'll meet. They're not parallel. They'll meet. If you produce them, they'll meet. So that's why we call PQR as a kite. Now, what are the other properties of a kite? A kite has two pairs of adjacent sides equal. Now see here, side PQ is equal to side PS. Also, side QR is equal to side SR. So in a kite has two pairs of equal length sides which are adjacent to each other. Two pairs, okay? Let's understand the phrases one by one. Two pairs of equal length sides. Equal length sides meaning two pairs of sides have the same length, equal length sides. A kite has two pairs of equal length sides that are adjacent to each other. Adjacent meaning next. We understood no what is meant by opposite sides, opposite angles, adjacent angles. So that's what it is. PQ and PS, they are adjacent sides. They are equal. RQ and RS, they are adjacent sides. They are not opposite sides. See, sides we have only two. Either they should be opposite sides or adjacent sides. That's all. Either they are opposite sides or adjacent sides. Opposite sides means they will not have any vertex in common. Adjacent sides will have a vertex in common. Now see here, PQ, PS. P is common, no? That's why they are adjacent sides. PQ, PS. P is the common vertex. That's why they are called adjacent sides. Similarly, RQ, RS. The vertex R is common. RQ, RS. The vertex R is common. So they're adjacent sides. They're not opposite sides. They're adjacent sides because they have a common vertex. And in a kite, adjacent sides are equal. Two pairs of adjacent sides are equal. And they are PQ and PS, which are equal, and RQ and RS are equal. Is this understood? Why nobody's acknowledging? Did not understand?
Yes, okay, ma'am. Understood. Yes, ma'am.
Okay. So that's about two pairs of equal length sides which are adjacent to each other. Next. In a kite, the diagonals, they are not equal. One is long, the other is short. In a kite, the diagonals are not equal. See the figure. In a kite, the diagonals are not equal. Which are the diagonals here in the kite? Name the diagonals.
Ma'am, PR, QS, PR.
Correct. PR and QS. Are you there, Srijit? Yeah. PR and QS, they are the diagonals. They are not equal. Not equal means like this. The length of the diagonal PR and the length of the diagonal QS will not be equal in a kite. It will not be equal in a kite. One diagonal is long, the other will be short. Understood this? In a kite, the diagonals are of unequal lengths. In a kite, the diagonals are of unequal lengths. Got it? Please acknowledge.
Yes, ma'am.
Okay. The diagonals are not equal. See, supposing I say PR. Supposing I say PR is some 15 centimeters, QS will be like, say, some 8 centimeters. They'll not be equal. Okay, next. The diagonals of a kite are perpendicular to each other. That means they meet at right angles. See here. The diagonals of a kite are perpendicular to each other. Perpendicular to each other meaning they make right angles. Where they meet, see, this is one diagonal, this is the other diagonal. Where they meet, no, they make 90 degrees. If this is 90, then this is 90, this is 90, everywhere it's 90 only. So that's the other property of a kite. The diagonals of a kite are perpendicular to each other. We write it like this symbolically. The diagonal PR is perpendicular to diagonal QS. PR is a diagonal, QS is a diagonal. Perpendicular, there's a symbol. There's a symbol for perpendicular.
Okay.
Okay. So two pairs of adjacent sides that are equal, and then no pair of opposite sides parallel. Diagonals unequal. Diagonals are perpendicular to each other. Now, let me draw the same kite with only one diagonal, okay, to explain some properties. Let me show only the longer diagonal. Let me show only the longer diagonal. Now, the longer diagonal is called the line of symmetry or the principal axis. It's called the line of symmetry because just imagine you fold the kite along this line of symmetry. The triangle on the right side will overlap. It will fall exactly on the triangle on the left side. If I call this the triangle on the right side and this one is on the left side, if you fold the kite along PR, you fold it, you make a crease and you fold the kite along PR, you will see that this right triangle falls exactly on the triangle on the left side. The triangles will coincide. That
Yes,
means they are identical triangles. When will they coincide? Only when they are identical. See, if you buy two notebooks of the same company, same brand, okay? If you keep same brand and same size, everything all same. 200 pages, small book, all everything same. They're two identical books. So if you place one book over the other, the top book will superimpose the bottom book. The top book will exactly cover the bottom book. Like that here, when you fold this kite along PR, the triangle on the right side will superimpose the triangle on the left side. It will exactly coincide with the triangle on the left side. That means these two triangles are identical triangles. These two triangles are identical. These two triangles are identical. Identical triangles. Which one? Triangle PQR and triangle PSR are identical triangles. So like if you have a chocolate in this shape and two friends want to share, you cut it along PR, you will get two equal pieces. If you break the chocolate along PR, both of you will have exactly, exactly the same pieces. They'll be identical pieces, the two of them. So PR is called the line of symmetry. PR is called the line of symmetry, and the triangles on either sides of PR are identical triangles or congruent triangles. So if they're congruent or identical, what happens?
What does congruent mean?
Identical.
Okay,
exactly the same. Exactly the same. So if these two triangles are congruent, what happens? This angle, see, when you fold, you know what happens? This angle will coincide with this angle. This angle will coincide with this angle, and this angle will coincide with this angle. Do you agree? When you fold the kite along PR, when you fold the kite along PR, you will see that this angle and this angle. So this angle will, sit on this angle, will fall on this angle. This angle and this angle, they'll coincide. This angle and this angle will coincide when you fold it. Yes or no?
Yes, ma'am.
So in the kite, so this angle is equal to this angle. Remember this, very important. You will be given a figure and asked to find you. Supposing you're given a kite, they'll give you very minimum information and they'll ask you to find the remaining angles or the unknown sides. So all that you can find only if you know the properties of the kite. If you know the properties well, you can answer. It will be a very simple question for you. If you don't know the properties, or if you don't, remember the properties, you don't take efforts to remember the properties, then that question will be difficult for you. An easy one will be difficult because you don't know the properties. So this angle, supposing they give you this angle is 40, this also will be 40. For example, supposing they give you this angle is 120 degrees, this also is 120 degrees. And if this is 20 degrees, yeah, 20, this also will be 20. Am I clear?
Yes, ma'am.
Okay.
Yes,
Now let's understand. Very good. Now let's understand the kite with respect to the shorter diagonal. With respect to the shorter diagonal. The longer diagonal, we understood. The longer diagonal is called the line of symmetry or the principal axis. Principal axis or the line of symmetry. Line of symmetry. Symmetry it is. It is symmetry. Met. I see children using an N here. No, symmetry. Don't pronounce it like some of us say geometry. We just put an N ourselves. So like that, some children read it with an N here. No, it's not that. It's symmetry, geometry, symmetry. Don't use an N yourself. I'm not saying you do that. If you're pronouncing it like that, correct it. Symmetry. Okay, line of symmetry. So the longer diagonal is called the line of symmetry, and the longer diagonal divides the kite into two identical triangles or two congruent triangles. And you understood that the angles on either sides are equal. Okay, and you also know that this side is, Srijit, disable your mic. You know that this side is equal to this side because it's a kite, no, adjacent sides are equal, and this side is equal to this side. This you already know. Adjacent sides are equal, we already know. That's the property of a kite. Now, with respect to the shorter diagonal, the shorter diagonal divides the kite into two isosceles triangles. Remember this, the longer diagonal divides the kite into two congruent triangles, identical triangles. The shorter diagonal divides the kite into two isosceles triangles. Why? Because these two sides are equal, no? And these two sides are equal. This is the shorter diagonal. This is the shorter diagonal. This is one isosceles triangle. This is one isosceles triangle. These two isosceles triangles are not identical. One is small, the other is big. They have different shapes, but both are isosceles triangles. They don't have the same shape. Okay. So the shorter diagonal divides the kite into two isosceles triangles. This is an isosceles triangle and this one is an isosceles triangle, but they are not identical. They don't look alike. They look different. These two triangles, they look different. But here, these two triangles are identical. The longer diagonal divides the kite into two identical triangles. The shorter diagonal divides the kite into two isosceles triangles which are not identical. Two isosceles triangles which are not identical.
Okay, ma'am.
Very good. So these are the properties of a kite. Opposite sides, listen carefully. Properties of a kite. Opposite sides not parallel. Both the pairs of opposite sides not parallel. Two pairs of adjacent sides are equal. Two pairs of adjacent sides are equal. Diagonals not equal. Diagonals are perpendicular to each other. Longer diagonal divides the kite into two identical triangles. Shorter diagonal divides the kite into two isosceles triangles. Now, one more thing I have to tell you is that the diagonals, the longer diagonal bisects the shorter diagonal. Now, what do we understand by this term bisect? Bisect means cut into two equal halves. Bisect. Bisect is different from intersect. Intersect means they just meet. Intersect is just meeting. Bisecting means cut into two equal pieces. Cut into two equal pieces. Intersect means just meeting. See, like now this is one line segment, this is one line segment. They intersect here. They intersect. They meet. That's all. Bisect means cut into two equal pieces. So, in a kite, the longer diagonal is like the knife. The longer diagonal is the knife. The smaller diagonal is like the cake. The knife will cut the cake. No, the cake will not cut the knife. The knife, you use a knife to cut the cake. The longer diagonal is the knife. The shorter diagonal is the cake. And you cut the cake into two equal pieces. So using the knife, which is the longer diagonal, you cut the cake, which is the shorter diagonal, into two equal pieces. So the longer diagonal is the knife. This one is the knife. The shorter diagonal, this one is the cake. And you cut the cake into two equal pieces using the knife. So the longer diagonal bisects the shorter diagonal. The longer diagonal cuts the shorter diagonal into two equal pieces. Which means PR is the knife. PR is the longer diagonal. That's the knife. Now, if this length, the length of the diagonal, supposing it is, say, some 18, it may be 3 centimeters here and 15 centimeters here. But the shorter diagonal says 12. For example, 12. It will be 6 here and 6 here. That is QO is 6, OS is 6. Because it's cut into two equal pieces. So QO and OS, they will be equal. QO will be equal to SO. Because the shorter diagonal is cut into two equal halves by the longer diagonal. So the shorter diagonal, in the shorter diagonal, QO is equal to SO. So if the shorter diagonal is 12 centimeters, then 12 by 2, 6. QO is 6, SO is 6. But the longer diagonal, PR, supposing it is 18, it will not be 9, 9. It will not be 9, 9. If it's 18, this portion may be 3, this portion may be 15, like that. That means what? The longer diagonal is not bisected, is not cut into two equal pieces. The shorter diagonal is cut into two equal pieces. The longer diagonal bisects the shorter diagonal. These are the properties of a kite. Next, properties of a parallelogram. Properties of a parallelogram. Now, in a parallelogram, I've been forgetting the trapezium in the middle. Sorry. Trapezium. Trapezium. In a trapezium, one pair of opposite sides are parallel. The other pair, this one, they are not parallel. One pair of opposite sides parallel, These are not parallel. All right. In a trapezium, the diagonals, they are not equal. They are not equal. The diagonals are not equal. I have the diagrams. Let me just show you like that. Okay. So regarding the kite, I didn't tell you one more thing. In a kite, this arrowhead is an example of a concave kite. Concave kite, arrowhead. Arrowhead. This is an example of a concave because you can see this angle is more than 180 degrees. It's a reflex angle. This one is a kite. This figure is a kite. Why is it a kite? Because adjacent sides are equal. This side is equal to this side, and this side is equal to this side. Adjacent sides are equal, so it's a kite. But it's a concave kite because this angle is more than 180 degrees.
Okay, ma'am.
Yeah. Now, there are other things in this, so I will ask you in the next class. I have not explained this one. Learn this, I'll ask you in the next class. Nothing. A kite is a tangential quadrilateral. Get the meaning of the term tangential. Browse and tell me what the meaning of the term tangential is and what is an inscribed circle. I'll ask you in the next class. The others I've explained. All this I've explained.
Okay, ma'am.
Yeah. So you can see here, one pair of opposite sides are parallel to each other. The parallel lines are known as the bases of the trapezium. These are the parallel sides. These are the parallel sides. The parallel sides are called the bases of the trapezium. And in this trapezium, this one is a short base or the shorter base, this is the longer base. In this trapezium, you can have a trapezium like this also. These two sides parallel. So then this is the long base. And this is the short base. So short base and long base, they can be above, below, anyways. Okay, depends on the figure. The parallel sides or the parallel lines, you make it sides, okay, not lines. Parallel sides are known as the bases of the trapezium. Okay, one pair of opposite sides non-parallel to each other. These two sides are non-parallel. These two are non-parallel. The non-parallel sides are called the legs of the trapezium. The parallel sides are called the bases, and the non-parallel sides, these two sides which are not parallel, they are called the legs of the trapezium. Legs of the trapezium. And what is the median? Median is a line segment which is parallel to the bases. This median is a line segment. Why is it a line segment? Because it has fixed endpoints. It has fixed endpoints, so it's a line segment. Median is a line segment which is parallel to the bases. Which is parallel to the bases, and it divides the legs equally. See, like if this one is 10 centimeters, it will be 5 here and 5 here. And supposing this is, say, 12 centimeters, it will be 6 here and 6 here. It divides the legs equally. It divides the legs equally. This is the median. Median is a line segment. It is parallel to the bases. It is parallel to the bases. And it divides the legs equally. These are the legs. It divides them equally. That means if the length of this leg AB is 10 centimeters, then AE will be 5, EB will be 5. If the length of this leg DC is 12 centimeters, then DF will be 6, FC will be 6. These are the properties of a trapezium. Parallel sides are called the bases. Non-parallel sides are called the legs. Parallel sides are called the bases. Non-parallel sides are called the legs. And the median is a line segment which is parallel to the bases and it divides the legs equally. That's about a trapezium. Yeah, this one I'll ask you in the next class because you have the figure also. It's easy for you to understand. I've given you the figure and the explanation here. You will tell me in the next class. Yeah, next parallelogram. Yeah. In a parallelogram, both the pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. Opposite sides are equal. Like in a rectangle, you know, opposite sides are equal. Only opposite sides, not all the sides. Only opposite sides are equal. Okay, so if it is ABCD, AB is equal to CD. BC equals AD. Opposite sides are equal. Opposite sides are parallel. Opposite sides are equal. Opposite angles are equal. Opposite angles. Angle A is equal to angle C. Angle B is equal to angle D. So opposite sides parallel. Opposite sides equal. Opposite angles equal. If this is 120, this is also 120. If this is 60, this is also 60. Opposite angles equal. Opposite sides equal. So if this is 7, this is also 7. If this is 10, this is also 10. And opposite sides are parallel. Okay. Then coming to diagonals. Diagonals are unequal. Diagonals are not equal. Diagonals are unequal. In parallelogram ABCD, the diagonal AC is not equal to the diagonal BD. The diagonals are not equal in a parallelogram. But the diagonals, they bisect each other. They bisect each other. See, when you talk about sides, you know, you can talk two things. You can say two things when you about sides. Opposite sides, are they equal? Are they parallel? Angles, opposite angles. For angles, you cannot say parallel, no? Are the opposite angles parallel? Doesn't make sense. So are the opposite angles equal? So ask yourself those questions. Opposite sides, are they parallel? Yes. And in a parallelogram, are the opposite sides equal? Yes. Are the opposite angles equal? Yes. Are the diagonals equal? No. Diagonals are not equal. But the diagonals, they bisect each other. They bisect each other means, listen carefully, they bisect each other means, if AC is the cake, then BD is the knife. If BD is the cake, then AC is the knife. Like that, they bisect each other. They cut each other equally into two equal pieces. That means AO is equal to OC and OD is equal to OB. The diagonals are not equal. See, if AC, supposing AC is 10 centimeters, it will be 5 here and 5 here. Now BD will not be 10 because diagonals are not equal. BD will not be 10. Diagonals are not equal. So BD is say some 12 or 14. It will be 7 here and 7 here. The diagonals, they bisect each other. One diagonal cuts the other diagonal into two equal pieces. That's the meaning. Bisect each other meaning one diagonal cuts the other diagonal into two equal pieces. Listen carefully. That means AC bisects BD. That means what? The diagonal AC cuts the diagonal BD into two equal pieces. Also, BD bisects AC. BD cuts AC into two equal pieces. That's what we say diagonals bisect each other. They bisect each other. That means AC bisects BD, BD bisects AC. So diagonals bisect each other. But they are not equal. Diagonals are not equal. AC and BD will have different lengths. But that if you take one diagonal, it's cut into two equal pieces. Is this clear?
Yes, ma'am.
The diagonals are not equal. These two diagonals are not equal. But this one is equal to this one, and this is equal to this. So if this diagonal AC, if diagonal AC is 20, it will be 10 here and 10 here. If the diagonal BD is 26, it will be 13 here and 13 here. So we say the diagonals bisect each other, but not at right angles. They only bisect each other. They don't meet at right angles. No, they don't bisect at right angles. So when we talk about diagonals, are the diagonals equal? No. Do the diagonals meet at right angles? No. In a parallelogram, no, they don't meet at right angles. Do the diagonals bisect each other? Or does one diagonal bisect the other diagonal? Yeah, here actually both the diagonals bisect each other. Okay, so these are the questions related to diagonals. Are the diagonals equal? No, they are not equal. Do the diagonals meet at right angles? Do the diagonals meet at right angles? No, they don't. Yes. I said yes, no.
No, ma'am.
No, they don't.
No, ma'am. Not in a parallelogram, but yeah.
Not in a kite, they meet at right angles, not in a parallelogram. Yeah. They don't. Yeah. So diagonals are not equal. They don't meet at right angles, but the diagonals bisect each other. They bisect each other. That means AC cuts BD into two equal pieces. BD cuts AC into two equal pieces. Now tell me the two equal pieces of AC. Which are the two equal pieces of AC? Name it.
OA, OC. Ma'am, can you repeat the question?
Name the two equal pieces of AC.
AC. AO, AC. AO, OC.
Correct. AO and OC.
Yeah.
Diagonal is AC.
And can't we not say OA and OC? You can tell. Yeah. It was also fine.
Correct. OA, OC. Correct. Then which are the two parts of BD? BD.
Ma'am, BD, OD.
OB and OD. OB will be equal to OD. Correct. Very good. Now, the other important thing is the diagonal. See here, this is one diagonal. This is the diagonal AC. This diagonal AC, it does not bisect the vertex angle. Now, supposing this angle is 120 degrees. Okay, if this angle is 120, it will not be 60-60. It will not be 60-60. Maybe this is 100 and this is 20 degrees. And we know opposite angles are equal, right? So this also will be 120 only. If this is 120, if this angle is 120 degrees, this angle is also 120 because opposite angles are equal in a parallelogram. But the diagonal it does not bisect the corner angles. It does not bisect the angles at the vertex. Just 1 second. Yeah, if this is 120, this also is going to be 120, but it will not be 60-60. The angle is not bisected. It's not bisected the angle. Okay, so maybe it is. Second.
Okay, ma'am.
I'm not getting the point of just yeah. So if this is 120, it may be 100 here and 20 here. It's not bisected. Now you'll ask me why you're not writing 100, because do you remember alternate angles are equal? Parallel line, transversal, parallel line. If this is 100, this only will be 100 because alternate angles are equal. Here the lines are parallel, no? These two lines are parallel. So parallel line, transversal, parallel line. Parallel line, transversal, parallel line, alternate angles are equal. So if this is 100, this will be 100. We'll take up that in the next class. For now, we understand that the angles are not bisected. Similarly, this angle, if this whole angle is 60 degrees, it will not be 30-30. It will not be 30-30. The angles, the diagonals do not bisect the angles at the vertices. This is the diagonal BD. This diagonal BD, it meets angle B and angle D. It meets angle B and angle D. It does not bisect the angle. It does not divide the angle into two equal portions. These are the properties of a parallelogram. Now, for a rhombus is a parallelogram. A rhombus is a parallelogram. So, it has all the properties of a parallelogram, but it will have its own special properties. That's why it's called a rhombus. A parallelogram, a rhombus is a parallelogram. So it has all the properties of a parallelogram, but it should have some unique properties, so some special properties for itself. That's why it has this name rhombus. So what are those properties? In a rhombus, all the sides are equal. In a parallelogram, only opposite sides are equal. In a rhombus, all the sides are equal. All sides are equal. That's one thing. Then opposite sides are parallel. Opposite sides are parallel. Diagonals, they are not equal. In a rhombus, diagonals are not equal. Diagonals bisect each other. Diagonals, they bisect each other. I explained already what bisecting means. In a rhombus, all sides are equal. Opposite sides are parallel because it's a parallelogram. If it's a parallelogram, opposite sides will be parallel. Because that is what is a parallelogram. A rhombus is a parallelogram. That means opposite sides are parallel. Then all the sides are equal in a rhombus. And in a rhombus, opposite angles are equal. Like in a parallelogram, here also opposite angles are equal. Diagonals, like a parallel. Sorry?
Ma'am, one doubt.
Yes?
Ma'am, rhombus and parallelogram, they are just like I don't know how to ask.
Yeah, they are mostly similar. Just that see, the difference is in a rhombus, all the sides are equal, but in a parallelogram, only opposite sides are equal.
Ma'am, no, why they are similar and why is it changing? Only side is changed in rhombus and parallelogram. Why so much differences are there?
Yeah, so that's what. In a parallelogram, when all the sides are equal, it's called a rhombus. In a parallelogram, when all the sides are equal, it becomes a rhombus. When that change happens, few other changes also happen.
Like square and rectangle.
Yeah, correct. In a rectangle, if all the sides are equal, it's a square. Similarly, in a parallelogram, only opposite sides are equal. But if all sides are equal in a parallelogram, it's called a rhombus. Okay, so in a rhombus also, diagonals are not equal. Diagonals, they bisect each other. Okay. But at right angles. Here they bisect at right angles. Here they bisect at right angles. They make 90 degrees where they meet. And in a rhombus, the corner angles are bisected. The diagonals, they bisect the corner angles. So like if this angle is 120 degrees, it will be 60 here and 60 here. 60 here, 60 here. And if this angle is 60 degrees, it will be 30 here, 30 here. The diagonals, they bisect the angles at the vertices. In a rhombus, the diagonals, they bisect the angles at the vertices. In a parallelogram, they don't. In a parallelogram, the diagonals are not perpendicular. Here, the diagonals are perpendicular.
Yes.
In a parallelogram, only opposite sides are equal. Here, all the sides are equal. So in parallelogram, opposite sides equal. Here, in rhombus, all sides equal. In parallelogram, diagonals bisect each other, but not at right angles. Here, diagonals bisect each other at right angles. In parallelogram, diagonals, they do not bisect the angles at the vertices. Here in a rhombus, the diagonals bisect the angles at the vertices. That's about rhombus. Okay, I've shared the material with you. You can go through all this. We have discussed all these properties, children. You can go through this. Next, rectangle. Just give me 5 more minutes. I'll finish the properties. Rectangle. So this is a familiar figure. In a rectangle, opposite sides are equal. Opposite sides are equal. Opposite sides are parallel. Opposite sides are parallel. Opposite angles are equal. In fact, all the angles are equal because each angle is equal to 90 degrees. All angles are equal. Each angle is equal to 90 degrees. Diagonals are also equal. Diagonals are also equal. Diagonals are equal. They bisect each other, but not at right angles. Diagonals are equal. If you call it PQRS, PR is equal to QS. The diagonals are equal, but they don't make 90 degrees here. They don't make 90 degrees here. They don't, they bisect each other, but not at right angles. Right angles meaning 90 degrees. Diagonals are equal. Diagonals bisect each other. See, in all parallelograms, diagonals will bisect each other. In a parallelogram, rhombus, rectangle, square, everywhere the diagonals will bisect each other. And in all these figures, opposite sides are parallel because they're all parallelograms. So opposite sides will be parallel. So in a rectangle, diagonals are equal. Diagonals bisect each other, but not at right angles. Now the diagonals are equal, right? So if PR is say 20 centimeters, then QS also will be 20. If PR is 20, QS is also 20. And we know diagonals bisect each other, no? So it will be 10 here, 10 here. It will be 10 here and 10 here also. Yes or no?
Yes, ma'am.
Because diagonals are equal. Yeah, diagonals are equal. So 20, 20, but they bisect each other. So that means PO will be equal to OR. So 10, 10. Also, OQ is equal to OS. So again 10, 10. So what do you observe then about these triangles? These are isosceles triangles. Which one? All these four triangles. The diagonals, they make four triangles, right? See, triangle 1, 2, 3, 4. There are four triangles, right?
Yes, ma'am.
Yeah, these four triangles are isosceles triangles. Isosceles triangles, because you can see 10, 10. These two sides are equal. 10, 10. These two sides are equal. These are isosceles triangles. All these four triangles are isosceles triangles because two sides are equal. The sides measuring 10 centimeters, 10 units, they're equal. So all these four triangles are isosceles triangles. And also in a rectangle, the diagonals do not bisect the corner angles. The diagonals, they don't bisect the corner angles. Now this is 90 degrees in a rectangle. It will not be 45, 45. 90, half of 90 is 45, no? It will not be 45. Because the diagonal does not bisect the corner angle. So it will not be equal. 45, 45 it will not be. 90, 90, no? So it will be like say some 60, 30 or 70, 20, anything. The sum will be 90. Maybe some 65 and 25. The total will be 90, but it will not be 45, 45. Everywhere. The corner angles are not bisected. The corner angles are 90 degrees, but the diagonals, they don't bisect the corner angles. So it will not be 45, 45 anywhere. That's about a rectangle. Okay, and I've shared these properties. Just a second. Yeah. Have you all completed writing the notes, children?
Yes, ma'am.
Yeah, I shared the notes before the first class. Yeah.
Yes, ma'am. We finished.
Okay.
Ma'am, I
I'll
also
check it.
finished the last 3 pages, ma'am.
Okay, I'll check your I'll check your work in the next class.
Okay, ma'am. Okay,
So that's about a rectangle. Now square, 2 more minutes. We'll wind up the session for today. In a square, all the sides are equal. Opposite sides parallel. In a square, opposite sides parallel. All the sides equal. All the sides equal. All angles equal. Equal to 90 degrees. Diagonals equal. In a rectangle also, diagonals are equal. In both rectangle and square, diagonals are equal. In a rhombus and a parallelogram, diagonals are not equal. In a parallelogram and rhombus, diagonals are not equal in length. But in a rectangle and square, diagonals are equal in length. And so diagonals are equal in length in a square, and diagonals bisect each other. In all the four, rhombus, rectangle, square, parallelogram, in all the four, the diagonals bisect each other. Okay, so here also diagonals bisect each other. Diagonals are equal and diagonals are perpendicular to each other. They are perpendicular. They meet at right angles. The diagonals, they meet at right angles. Diagonals are equal. Diagonals bisect each other. Diagonals meet at right angles. Now, the diagonals in a square, they bisect the corner angles. They bisect the corner angles. Very important. In a square, the diagonals, they bisect the corner angles. And we know every angle in a square is 45. Sorry, 90 degrees. It's time, no? So now I'm just 1 minute. Okay. So in a square, every corner is a right angle. The diagonals, they bisect the corner angle. So it will be 45 here, 45 here. The diagonals, they bisect the corner angles. Corner angles, meaning the vertex angles. 45, 45. Here also it will be 45, 45. Here also 45, 45. 45, 45.
Okay, ma'am.
Meaning in a square,
Okay.
no angles are fixed. Angles are fixed. There's nothing that you have to find in a square. All angles are fixed because this is 90. This is also 90. This is 90. This is 90. So any square, whether big or small, any square, whether it's a big square or a small square, they need not give you anything. You can fill all the angles. This angle is 45. This angle is 45. This is 90. This is 90. This is 90. This is 90. This is 45. 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 It's fixed. It's fixed. So diagonals are equal. Diagonals bisect each other. Diagonals meet at right angles. Diagonals bisect the corner angles. Opposite sides parallel. All sides equal. All angles equal. Correct? Diagonals, they bisect at right angles.
Yes, sir.
Okay. So this image I've shared with you. All sides equal, opposite sides parallel, right angles, diagonals are equal, diagonals bisect each other, they are perpendicular to each other. Then the diagonals bisect the interior angles at the vertices. That means I said no corner angles. Interior angles at the vertices, meaning the corner angles. Diagonal AC bisects angle A and C. That's what I explained. Diagonal AC bisects A and C. This is the diagonal AC. It bisects angle A. That means 45, 45. It bisects angle C. Diagonal BD bisects angle B and angle D. I said bisects means divide into two equal parts.
Okay.
All right. So that's about the properties of the special quadrilaterals. Please go through the notes I've shared. I'll also share the recording. Maybe you can watch the recording. Okay. I'll share the recording. Please watch the recording. Come prepared for the next class.
Okay.
So we'll take up numerical situations from this chapter. Only if you know the properties clearly, can you answer the questions very easily, very comfortably. If you're not sure about the properties, you'll have a tough time with the questions. And I don't want you to have a tough time.
Okay, ma'am.
All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you.